Thank you. Right, so my name is Josh Long. I'm the developer advocate for the Spring technologies at Pivotal. Email and LinkedIn and GitHub and all that stuff. Find me online. Twitter. How many of you are on Twitter? It's 2015, so Twitter. Okay? It's more useful than email. Now, if you have questions, if you leave this room more confused than when you came in, send me email. I am here for you. The code I'm going to look at is on GitHub. It's at github.com/joshlong/Bootiful Microservices. I am, as I mentioned, the developer advocate for the Spring team at Pivotal. I am the author on 5 different books on building distributed systems with Spring. The latest and greatest is an O'Reilly book on building microservices with Spring Boot and Spring Cloud. I am a Java 1 rockstar, a Java champion, and open source contributor to many different projects, and generally the leading contributor of bugs to all the various Spring projects. Leading contributor, very proud. Right. So I work for Pivotal. How many of you know what Pivotal is? We're a small, tiny startup. We're a startup in the valley, in Silicon Valley, with about 2,500 people. And our goal is to help developers build applications that work well for modern workloads, right? Modern use cases. And today that means microservices. That means building applications that work correctly in the cloud, right? Building an application today is very different from what we used to do 10 years ago. And the use cases that we have to serve are very, very different. Invariably, without a doubt, eventually, your applications will need to scale out, right? And this implies doing things a different way, right? If our applications today are different, then why should we build them using the same terrible ideas from 15 years ago? Instead, prefer the new cloud-native architecture. This architecture has 2 pieces, okay? When we talk about cloud-native, we mean NoSQL, big data on one side, and then we mean functional decomposition, service decomposition using microservices, okay? So microservices and big data. These are the 2 ways to build applications that live and breathe naturally in the cloud. In my talk today, we're going to talk about building microservices. We can leave the NoSQL and the big data for another talk later on. Later on, I will have a talk on using Cloud Foundry and Lattice to run and build, to scale out and manage applications in the cloud. Those are 2 different platform as a service technologies. So, we agree that we need to build applications differently. We'll talk about that today. The thing is that when you move to this architecture, you have to create lots of small services. And this creates problems, okay? It gives you benefits because you can scale, but it is harder to manage. There's complexity involved in services that call other services. You get pain, right? And this is where Spring Cloud, which we'll talk about today, can really help. I should mention that later on, my friend Mr. Kotin, he's got a talk later on Spring Cloud as well, that will talk about design patterns. So those are more specific. I'm going to be talking about just code. We're going to be going through a lot of different things today, okay? So check out his talk as well. When we talk about building microservices, there's a lot of patterns, a lot of things that you need to know in order to make this architectural jump. Thankfully, we don't have to do it alone, right? That's the whole point, is that the big web giants, the giants of the internet, have already moved to this architecture, and they have already figured out where the pain is and how to avoid it. There's a company in the States called Netflix. How many of you have heard of Netflix? Netflix is a streaming video company, but they're based on the cloud. They live in the cloud, and they're famous in the West for building this kind of architecture. They have more streaming video than YouTube, 200% more. A lot more. In fact, on the internet as a whole, in the United States, every night, in the evening hours, Netflix is 80% of the traffic 80% of all internet traffic in the world in the evening hours in the United States is because lazy, fat Americans are watching TV. This is how we are happy in so web scale, okay? Now, they have so many streaming videos that the only thing on the internet that has more bandwidth and more usage is pornography. So porn as a concept, and then Netflix. Crazy scale, right? And you don't build this kind of scale using WebSphere. Nobody does that, okay? So we're going to talk about this new architecture, and we're going to talk about design patterns related to this architecture. Those are my slides. What do you think of my slides? Those are good slides, right? I worked hard on those. There's 2 of them. Moving on. So, how many of you remember my talk last year I did on Spring Boot? Anybody? Spring Boot? Okay, I'll give you a quick reminder. Spring Boot is, I think, the simplest way to build an application today. It's the simplest way to build a service. I can show you the Java code, but we are going to content ourselves to look at just regular, we'll use something called Groovy, okay, which is a programming language. So I'm going to build a simple service, touch hello.groovy, and I'm going to open this up and wait for the editor to load because it's based on Chrome and it takes forever. Okay, REST controller, class greeting, REST controller, like so, and def high path variable, string name, and I'll say I'm going to return a payload that looks like this. This is an anonymous object, like JSON, sort of, in JavaScript, okay? And all I'm doing is I'm creating a REST endpoint that will listen for requests at /hi/name, and I'm going to run it. Actually, I'm going to go here. I'm going to also add grab Spring Boot starter actuator, okay? That's going to bring in a Maven dependency. It's basically org Spring Framework boot Spring Boot starter actuator, and then it'll bring in version, whatever that is, okay? That's what's happening here. So I'm going to run this little script, go to the command line, and I have a Spring command line tool, Spring, right there, see? If you have GVM, you can do JVM install Spring Boot. If you have Homebrew on the Mac, you can do brew install Spring Boot, whatever. It's just a utility, okay? And the nice thing is that I can say Spring run hello.groovy, and then I get an application. A couple of things are very important here. Look at this. First of all, this ASCII artwork. Have you seen this? Oh, that's so good. So good. Now, I have spent a lot of time talking to the savage Node.js developer. Their primitive minds need the ASCII artwork. It helps them to understand. So this is the way to communicate. This is the way to bridge the gap so that we can communicate with them. Use ASCII artwork. It's very, very good ASCII artwork. On the Spring team, we have 2 doctors, 2 PhDs, 2 people that have, in their previous lives, worked on nuclear physics. Nuclear physics. It makes me so happy to imagine that one day they had a GitHub issue or a Jira issue that says, we need good ASCII artwork. Please, deliver. And they did, and it's amazing. It's a very amazing thing. So anyway, our application's up. Go here, localhost, and I can say hi, right? And there's my simple REST service. And if I make requests like this, I can make a lot of requests. Then I go to /env, and you can see that there's all this environment information. If I go to metrics, you can see there's the memory. I made 23 requests to /hi/name with status code 200. I get the health endpoint. I get all of this stuff for free, right? Well, it's not down, but I didn't customize it. So all of that is very, very simple. And in fact, I can do Spring jar, hello.groovy, hi.jar. Whoops, wrong way. So there you go, hi.jar. Okay, and then I can do java -jar, hi.jar. And it gives me the same thing, including the ASCII artwork. So very, very easy to manage this. In fact, if you put that jar in an email and then send it to somebody, even my grandparents have the ability to run Java applets. So it's very easy to run this in production. You don't need, WebLogic and Tomcat or all this craziness, if your operations team have trouble with this, then I will tell them to talk to my grandpa, because he can help. He can help. Okay? So, anyway, that's very easy to build a single service. What we're trying to do today is to build lots of services. And so for this, we need Spring Cloud. I'm going to start at start.spring.io. This is a wizard. I have a choice to pick different types of technologies that I want to support. So the first thing I'm going to do right now is I'm going to build a web application, and I'm going to use JPA, okay? I'm going to generate, here we go, show in Finder, and I'm going to say reservations, open, reservations, good. And I'm going to build a lot of these services, so just, as we move along, realize that I'm going to start at start.spring.io each time. Oh, man. Come on. Faster. So, source main Java demo application. I'll make the font size bigger here. Good. Bigger. 30 minutes. Here we go. Good. So now I have my class. I'm going to say REST controller like this. Class reservation REST controller. Okay. And I'm going to create a JPA entity like that. Class reservation. Very similar. And it's just going to be private long ID at generated value. So this is just standard JPA, nothing fancy. Okay. I'm going to have a string, a private string reservation name. And then I'm going to have getters. Okay, and another constructor and another one. Okay. This is for JPA and nobody else. Nobody likes JPA. Good. So there's this, very, very simple. I'm going to print out toString, and then I'm going to create a bean that will get started when the application starts up. So I'll say bean command line runner. Okay, and it's a lambda, okay? So I'm using Java lambdas here, but this is what it looks like otherwise. Looks like that. And I'm going to inject a bean that I can use to manage my data. So I'll say interface reservation repository, and this is going to bring in Spring Data repository. Okay, and it's going to be reservations of type like this, and then I'll inject it here. I'll say reservation repository, good, RR, and I'm going to say arrays as list, Josh, Nicola, Artem, Oleg, split for each n rr.save, new reservation. Okay, so I'm saving data in the database, and then if I go down here, I can say rr.findAll.forEach system out print line. So that's going to print out everything in the database. I need to configure my database, so I'll go over here and I'll say, okay, good, I've got H2, okay, voila, that's an embedded in-memory database, and Spring Boot will automatically configure that for me. This is a lambda. There's no reason not to use lambdas here, so I'll use Java 8 lambdas. Replace with lambda, good, much cleaner. So if I run this, I should be able to see run Java demo application. Okay. So you can see the data is printed out. We have data being written to the database. It's a very simple REST service. And of course, the ASCII artwork is there as well. So everything is good, right? If I go to my browser, I go to localhost, /reservations, you can see the data is not there yet. We haven't written a REST controller. So let's do that right now. What I'm going to say is reservation REST controller, and I'll say private reservation repository like this, and I'll say at autowired, and I'll say at request mapping reservations, I'll say collection of reservation. Okay, return this.reservation repository.findAll. I'm going to run this again, and that's going to stand up a REST endpoint that will respond to any requests there, okay? So refresh, and there's my REST data. Good, so now we have a basic service we can play with. The next thing we need to look at when we build multiple services is having configuration, like database passwords and security information and ports and things like this in a single place. Because if you have one service, it's not such a big deal, you know. But if you have 10 services, or if you have encrypted passwords, you don't want this stuff to be managed randomly. You want it to be in a journal so that you can say, oh, well, somebody changed the password and now my system is broken. Or they changed something in production and everything fell down, right? You need something where you can roll back correctly. So the next thing we're going to look at is how to use the Spring Cloud config service to centralize configuration. And if we want to, we can also decrypt passwords centrally. We can say, okay, here's the configuration server. All the other services will talk to the config server to get their passwords, and they'll get their credentials, and they'll get their configuration, okay? So that's the next thing we're going to build. We're going to go back here to start.spring.io. I'll choose Java 1.8 again. And now I'm going to say config server, okay? And then that's it. I'm going to download that. Here we go. And I'm going to go back here, config server. Okay, unzip, config server. And what I want to do is to have a service that runs, and all the other services will talk to it. And then it can do things like say, okay, well, for dev, here's your configuration. For production, here's configuration, etc. So this is also a Spring Boot application, but I'm going to use the Spring Cloud config server. It's going to say Spring Cloud, no, @enable config server, okay, like that. And then I need to tell the config server where to find its configuration files, right? It's going to manage a Git repository, a Git source code repository, so that we can do, you know, journaling, we can roll back, we can do auditing and all this stuff. So I will go to my application properties, and I'll say Spring Cloud config server Git URI equals, in this case, I'm going to just point it to my local machine, okay? So desktop, here we go. Where is this? If I go here, JEEConf, cloud, microservices, here we go. So this is the one I want. And we need that. So it's here, JEEConf, okay, like that. Good. There you go. So that's the config location on my machine, localhost, okay? And then I'm going to tell this to run on port 8888 so that all the other machines can find it there if they need to. You can change it if you need to, but for now this will work. So we're now going to run this. I'm going to go to my config repository here, see, and I'm going to say git init, git add, git status, git commit, initial commit. Okay, so now I've added these configuration files, and these are going to be configuration files that other microservices will use to configure themselves in a single place. Now I run this. Okay, and if I go to localhost 888, you can see that the configuration for Eureka service is right here. So I go to Eureka service /master, and I can see the configuration values are in this configuration property file. And if I want to use these values, I can. So here's a message in the Eureka client, in the Eureka service. Let's say that I want to create a file for the reservation service, okay? So what I'm going to do is I'm going to go back to my reservation service here, and I'm going to give it a new file name called bootstrap.properties. Here we go. I'm going to say spring.application.name equals reservation service, like so. And I want to have a configuration file called reservation service dot properties, and I'm going to say git add reservation service. Hello, git, oh, cat reservation service. Oh yeah, it's already got that. So Joe reservation service. I'm going to say message equals hello JEEConf. Okay, git add or git commit rather, adding updated message. And then I want this service to get the configuration in this config file. So when I restart my reservation service, I'm going to inject the value. I'm going to say that when the data starts up, actually, I'm going to say that I'm going to create a REST controller, okay? Another REST controller. And I'll do this. I'll say class message REST controller. And I'm going to say at value, like so. And I'm going to read this message from the config file in the reservation service. Okay, and I'm going to make this refreshable because I want to be able to change this configuration live without having to change everything later. Okay, so we'll come back to that in a second. And then I'm going to say request mapping, message, string message. Okay, return this dot message. I want this to be able to get its configuration from the config server. So I need to go back to my build and add what I have here, which is the this dependency, first of all, to the Spring Cloud dependencies. That's the first thing. And then I need to add the Spring Cloud config client. So I'm going to say Spring Cloud config client, and then there we go. And once I have this, I can now, in here, I can say refresh scope, and I can restart the application. Okay, restart the service. Whew. Pouring sweat. Good. So reservations, that's still there, isn't it? Oh, probably not. I changed it, right? So reservation, hello, cat reservation service. Server port is 8,000 now. So it's not 8080. So there's reservations. And if I go to message, you can see it says hello JEEConf, right? But that's not a very good message. I think that's a terrible message. I think it should be more excited, you know? So what I will do is I will go to my config file here. I'll say Joe reservation properties, and I'm going to say hello JEEConf like that, okay? Get commit, updated. And if I go to the config server, you can see that, it's visible already, right? So reservation service, it sees the updated value, but this does not. In order to change that, I can do curl -d. This is an empty HTTP post, okay? Localhost :8000 refresh. I'm going to send an empty HTTP post to this. What did I do? Refresh. Did I change anything else? Oh, I don't have the actuator. Yeah. Dependency, Spring Boot Starter Actuator. This is going to add endpoints that my system will need in order to function, including the ability to reload things. So we'll do this again, this time from the start. So that's the old value, of course. Now, if I do that, still not there. Oh, thank you. I moved too fast. Thanks, man. I forgot the last word, the important part. Let's just make sure this is all working. There, it's responding. Now I can go to the class path here and I can say Joe, reservation service, ×2, right? Okay. Get commit, adding update. Now I go back here and I can say, it's visible in the config server, but it's not visible here yet. I go here now and I say curl -d, and I can refresh and I can see that the value has been changed live in the code. I didn't have to restart the service. So imagine you have 10 different services and they need configuration. This is very, very natural. Okay, so we looked at configuration. There's a whole lot more to look at. Now let's look at how to build a client to the service. If I'm in a microservice architecture, I have lots of services up and running and they need to find each other. They need a phone book so that they know who to call. In order to set that up, we use a service registry, okay? A service registry is like a phone book for cloud services. There are many different options for service registries. The one that we're going to use is called Eureka. It's the Eureka server, okay? So I'm going to go hit generate again. Open this. Command C. Eureka. Service. Okay. Eureka server. Open this up again. And this is going to be a Spring Cloud client as well, but you can see I've added Spring Cloud Starter Eureka server, so that's already there. I'll add Spring Cloud config client just as before. And what I'm going to do is I'm going to go to my application and I'm going to add @enable Eureka server. Okay, Eureka server, just like before. I'm going to configure it just as I did before as well. So I'm going to say application.properties server.port is equal to 8761. Now, of course, as you remember, we have the config server, so I don't actually have to put that here. Instead, I'll tell it to use this. I'll say, look at the config server and look at the Eureka service. The port will be specified here. Also, I have these other properties, so I'll leave those as well. In order to configure that, I need to specify spring.cloud.config URI is equal to localhost. This is where the config service is living, okay? And I need to put the Spring application name as well, that's all. So bootstrap.properties, spring.application.name equals Eureka, it is called Eureka service, right? So Eureka service, and there we go. So now if I run this, I want other services to register themselves with this. And then if I want to ask a question, I want to say, hey, where is the reservation service? I can go to the registry and it'll tell me, oh, this service lives on this host and port. It's here, here, and here. You can send a request. And that way, if I'm in the cloud and the services are going up and down, they all live here. I don't need to know the host and port. I'm decoupled from their location. So to see this working, I go to localhost 8761, okay? And you can see there's a service registry here. Eventually, individual services are going to register themselves here. They're going to make themselves available. This is the beating heart of your application. You don't want this to be available, to be fallen down, right? You want this to be available all the time. So you must set it up in a highly available mode with multiple instances. If you don't, it will get very, very angry at you. See? Where's my replica? Where's my replica? Is the replica available? No, there's no replica. So it's upset. And I understand why it's upset. I would be upset. You should be upset too. But we don't have time, so we're going to let it be upset. Fine, okay? Moving on. I want my reservation service to register itself here, okay? So I'm going to go back to the registration service, and I'm going to say dependency Spring Cloud Eureka, okay? And I'm going to tell it to act as a client to Eureka. And it's going to find everything it needs that way. So what else? Application.properties. The other thing I need is, yeah, that's it for now, I guess. Oh no, I need one more thing. I need the node that the config server lives on. So I'll take this, config server, Eureka, Spring Cloud, config, URI is equal to HTTP localhost 8888, okay, reservation service. I'm going to put that in Bootstrap, and that'll be basically the same for all my services. And then everything else should just work fine, so refresh. Here we go. Now this is going to take about 30 seconds. So eventually, this service should be visible here. You'll see it in this list. And this is a REST API as well as a human-readable dashboard. So you can use the REST API to say, hey, where does this service live? Is it available? If so, where? Now let's see if it started up. We should see the config service, the reservation service bit. Do we have it in here? Come on. Thank you. There we are. I'm forgetting one last piece, moving too fast. @enable discovery client is the generic one. We'll use that instead. And turn that feature on. Thank you. Okay, moving on. Always forget this piece. So it'll take about 30 seconds. We'll see that in here. In the meantime, let's start the next service, okay, the next thing. So the next thing I want is to be a config client, right? So we'll use that, but we'll change it. We don't want to be a Eureka server. We want to act as a client. I want to use Feign, Hystrix. I want to use Ribbon. I want to use, what else do I want to use? Anything else? Zuul, fine, great. And I want web support, and then that's it. It's Java 8. Okay, it looks like, by the way, if I go here, you can see now, it says reservation service. So it automatically got registered here. And if I go here, you can't see it on the bottom right of my screen down here, right here, if you look there, it says, you know, JL:8000/info. So that's one instance that is available on this host. That's the host of my machine, and it tells you the port. So other services now can ask, where's the reservation service? Well, this will tell you. Anyway, we have our download now, download 14. Okay. I'm going to take this here, and it'll be client, reservation client. Okay. And we'll say reservation client. A lot of stuff here. Moving on. I need to change the config server to just be config client. Leave that alone. I need to set up the application properties and the bootstrap properties just like before, so I can tell it where to find the config server and what its name is, right? So bootstrap.properties, and I'll say bootstrap.properties is going to be reservation client, and I'll tell it to look for the config here, and the config client here, you know, if you see cat reservation service, cat, well, that's enough, I guess. We'll just leave that alone. So that'll be enough. So what we want to do now is build an application that has discovery client, right? It'll be registered automatically. We want to enable Feign clients for declarative REST services. And we want to enable Zuul micro proxies, okay? So we'll turn on all these things, and we'll build beans that demonstrate different ways of talking to these other services. The first one we're going to build is just going to be using the low-level discovery client API, okay? The discovery client is an API that you can use to programmatically ask questions of the registry. You can say, where does this service live? Discovery client, get instances, reservation service, okay? And what I get back there is a collection of instances like this. And I'm going to say instances for each, and I'm going to say for each I, print out the I dot get host like this, I dot get port, and I will say print out I dot get service ID like that. Okay, good. So that should load up, and it should print out everything in the registry for this one service manually. If there's 10 services, I will have 10 instances here. Okay, so you can see it worked already. I've got the information already out of the box. I can now talk to the discovery client. It's looking for the registry on localhost 8761 by default, but you can override that. This is one way to go, but I think it's a little too low level. It's it's just hosts and ports. I want something higher level. I want to make a REST service call. So now I'm going to say, let's use the REST template like this. So command line runner, REST client. And I'm going to inject the REST template, which is a Spring API for building REST calls. Okay, this has been around in Spring for the last 5-6 years. How many of you have used the REST template? Okay, so the REST template is very powerful. You can configure interceptors. So I'm going to say, let's make a call to HTTP localhost. I'm going to say reservation service. I'm not going to give it a host or port. Okay, /reservations, and then let's pass in HTTP method get. Okay, and I want to call null for the request entity, and I want to get a object that has a collection of reservations. Okay, so I'm going to create a local type. Remember, reservation service is a REST service. I used Java and Spring, but I could have used any other language, any other platform, right? So I don't know if I have the shared types. In this case, I'm a client to another person's REST service. So I'm going to create a local type. I'm going to say private string private string reservation name. I'm going to say private long ID, and I'll just say getter, okay? And that's all. I'm not going to do anything. It's not my own entity. I'm just calling somebody else's, okay? So we're going to say select none. Good. And then what I want to do is I want to tell Java, listen, I need to get a list of reservations back. So in order to do that, I need to use generics. But generics don't work here. They're not going to do a good job because generics don't understand the type of a instance variable. Okay? You have this pattern in Java 8, or in Java in general, called the type token pattern. And basically, if you ask a generic type, like a list, if you have a list of foo, this information is gone at runtime. Yeah, it's gone. It's because of type erasure, right? So in order to keep it, you have to create an anonymous subclass. That's what this is. Okay, so I'm using this parameterized type reference, and I'm saying, give me list of parameterized type reference. Okay, so now, when I assign this to a variable, list response entity, I get that back. And then from the list response entity, I can get the body, and the body is a list of reservations. So I'm going to say for each reservation, system.out.println are toString, okay? And I'm going to create my own toString here again. And now if we run this again, remember, I'm using a service ID. I'm not using a specific host and port. This is in Eureka. This is in the service registry. There's no host and port. But the REST template knows about the service registry. So it'll go to the service registry, find the first instance, and then send the request for us, okay? So run this again. Oh, wow. There it is. So there's the data coming back from the database, or from the REST service in this case. And you can see it's just marshalling the data for us using JSON, and it's correctly marshalling it into objects. So I'm using HTTP, I'm using REST, I'm automatically discovering the right host and port, but I'm not coupled, and I can move the services around, I can register 10 or 100. This is important. As a client, I don't want to be coupled to the routing behavior on the router, right? If the service goes down, as a client, I am in a better position to decide how to change or behave differently. I am in a much better position if the service goes down to say, oh, well, I'll do something else. So I don't want the router to do load balancing. I want to do load balancing on the client. That's why the instance thing that we see here, it shows you all the instances of the service. If there's 10 different IPs and ports, this will give you 10 instances. Same thing happens here. This automatically loads all 10 instances and says, oh, well, I'm going to pick this one or pick this one. By default, it uses round robin load balancing. But you, with software, can change it. You can say, let's do availability zone specific load balancing, or do multi-tenant load balancing, right? So you can plug in the algorithm. It lives with your code. It doesn't belong on the router. This makes it so that your code can react when something changes. It's your ability to move and be more agile. So this is very nice as well, but I think this is too low level. We can do better, okay? So now let's build an interface, a declarative interface. I'm going to say reservation client, and I'm going to say collection of reservation, find reservations, okay? I'm going to say at request mapping. I'm going to say value equals reservations, method equals request method get. I'm going to say at feign client, okay? And I'm going to say this is a client to the reservation service. I'm not specifying a host and port. I'm just saying this is a client. And I'm declaring it using Spring MVC mapping annotations. So I'll define another bean here. I'll say at bean, command line runner, feign clients, example, CLR. Great. So I'm going to inject this interface. I'm not going to define the bean. Spring will do it for me. Okay, so RC. And I'll say return args, and I'm going to use rc.get or find reservations, and this will give me a list of reservation object backs. And then of course I can say reservations dot find. Hello. Oh, thank you. Moving too fast for my own good. Reservations dot for each r system.out.println r, and of course, if you know Java, then you know that this is completely wasteful, so just do that. It's much faster. Okay, so there you go, a method reference. I'm not even doing it. And of course you don't need this now, right? So get rid of that as well. I'm just gonna call that method and then print out the results. Very, very simple, much nicer. Good. So run that again. Okay, so there it's printing out the records again. So Josh, Nicola, Artem, Oleg, 1, and then again for the second time in the second client. So I've called the same service. I've looked up information about the same service 3 times, 3 different ways, using the low-level discovery client, using the REST template, which is more, it's REST, but it's also nice and type safe, and using the feign client, which is completely type safe. You don't even know that you're dealing with a remote service. So if you move to this microservice architecture, you want the ability to be unaware of, all the pain involved in working with these services, but you should still be able to recover if something goes wrong. What happens in this case if my service goes down? How do I guarantee that things work? This is where the circuit breaker comes in, okay? So I'm gonna go back up here, and I'll say @enable Hystrix, okay? Hystrix is a circuit breaker, and it's a way of guarding code that may fail, right? If you work in a distributed world, you may have service failure. So I'm gonna say reservation integration, and I'm gonna say @autowired, I'm gonna say private reservation client, like this, and I'm gonna say Hystrix command, and I'm gonna say, okay, fallback method equals get reservations fallback, okay? Collection of reservation, okay, get reservations, fine. Paste all this in there, just to make sure we're on the same page. And I'll define another method that I want to be called if something goes wrong, okay? This is gonna return just an empty array list. So I'm gonna say collections.empty list, okay? There we go. And what I'm gonna do is I'm gonna say, okay, let's make a REST call from the reservation client. I'm gonna get the reservations, but if something goes wrong, if that service isn't available, it's gonna throw an exception. And in this case, it'll call this method instead. This way, I can gracefully degrade, right? Think about the human body. The human body is like a microservice system. If you cut your finger, you don't blue screen, right? Things continue to work, hopefully. The same should be true of a big system. So in this case, I'm gonna build an integration, and I'll build a REST service that talks to that integration. So I'll say class, reservation, client, REST service, whatever. I can do more interesting things, but we're kind of out of time, so private, okay, request mapping, custom reservations, whatever, collection, reservation, return this dot reservation integration dot get reservations. And so when I call that method, it's going to either complete successfully or it's going to fail and return an empty array list. So I'm going to run this code again. The other thing is that, remember, I set up a proxy. I set up a micro proxy. Okay, so we'll come back to both of these. The way that this is useful is that if I am a HTML5 client or a iPad or an iPhone or something, I don't want to talk to every different microservice. I want to talk to a gateway, something that is on the edge of the internet, on the edge of the cloud, on the edge of the cluster, that can change and do security and do all these things as a proxy, sort of. Okay, so this application now is now its own service, its own port, and so on. It's on which port? Well, it should register anyway. We should see reservation client. Come on. Port, oh, okay, fine. It's on the client. This is a new endpoint, and I'm gonna say custom reservations. And there's my data, great, right? I've got my data. And remember that micro proxy, in this case, all I'm doing is I'm returning the data directly. So I have a service that's just showing the same data as the other service. But I can also, instead of doing this, I could just use a proxy, which is what Zuul is, right? So in that case, I could have said reservation-service reservations. And that would have proxied the data for me directly. I didn't need to write that code. The nice thing about what I just did, though, is that, in this case, it has Hystrix. So remember, our service is up and running, but I want it to do something correct if something falls. So where's my reservation service? There it is. This is the reservation service. I'm gonna kill it, okay? I'm going to do terrible things. I'm going to murder it. I'm going to hit exit. Okay? Goodbye. Now, if I go to my registry, you'll see it's no longer there. And if I go here, you'll see that I get an empty array list. So it gracefully degraded. It showed me something useful, even if the service is down. If I'm building a complex system where I have lots of circuit breakers, I want to be able to visualize these circuits. I want to see where things are failing. And so the way to do that is to use a Hystrix dashboard. Okay, so I'm going to hit generate one more time. Oh boy, here we go, so close. Command V, Hystrix dashboard. Oh my God. Do we have time? Will it happen? Can he do it? This is the question that we will all ask ourselves. Come on. Go, 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 go. So it's the same as before, same Spring Boot. Oops, Java 1.7. Don't use that. Here we go. @enable that. Demo application, and I'm going to say @enable Hystrix dashboard. And I'm going to run this now on another port just to make sure. Server.port equals 0, or actually, whatever, leave it like that, who cares? And then we're going to run. Okay. So I'm going to bring back my reservation client, my reservation service, I mean. That's reservations, here we go. We'll start this. And this one, my Hystrix dashboard, should be here now on 8080. Okay. So it's a dashboard. This is what I just set up. I want to see all the circuits that are broken, all the things that have had trouble. And the circuits, if you remember, lives here. Port 87, port 62, 6493, whatever, here. So I say /hystrix.stream, okay? That's what I'm saying, localhost 6294, whatever, hystrix.stream. I'm gonna hit monitor, and it's gonna show me, oh, look, here's your Git reservation circuit. Right now, it's closed, okay? I'm gonna open this, move it over. I'm gonna make requests. Remember, this one was open before, because here, if I make requests, you can see I'm getting empty, and it's showing me, look, blood. Something is wrong. We need to fix this, right? It's showing it's open. If I make more requests, you can see this is still failing, and it's showing me a moving average. But remember, I just restarted the service. So now the service is available here, right? That circuit should soon start to work, and now you see it's working over here, see? As soon as the service comes back online, the dashboard shows green. When the service was down, it showed red. So we have, in less than 45 minutes, looked at why I'm awesome, right? We looked at those slides. That was a good 5 minutes. That was a lot of time just to talk about me. Then we looked at Spring Boot and how it makes it very simple to build something very, very quickly using Groovy or even using Java. And then I built a simple service using Spring Boot, the reservation service. Then we looked at the config server and how we can use that to centralize your configuration and handle things like security in a single place so that if something goes wrong, you can see what files were changed, what configuration was changed. Then we looked at how to connect all of our services to a service registry. I looked at Eureka, but you could have also used Consul or Zookeeper or Cloud Foundry or Lattice or different other implementations. Then we looked at 3 different ways to consume services while not being aware of the specific host and port, right? We want indirection. I want the ability to say, call that service. I don't care where it lives. We used the low-level discovery client, then we used the REST template, and then we used Feign, which is higher level and object-oriented. Finally, we looked at how to build a service client and then call something that may fail using Hystrix to make sure that we have a safe default backup. And then finally, we looked at the Hystrix dashboard so we could visualize where things went wrong. What do you think, guys? Okay, good. Thank you very much. Thank you, thank you.
Please introduce the next talk. You will be here with Nicholas Frankel.
Oh, I'm gonna be right here. So the next talk is even better, or you should not miss it. It's gonna be amazing. People are gonna be like screaming. They're gonna be so happy, so happy. It's Nicholas Frankel and myself talking about Spring and Vaadin as a component-oriented UI framework. We developed the boot integration for that. So if you like component-oriented, UIs, this is probably a good talk to be in. After that, I have a Cloud Foundry and Lattice talk, and then after that, there's a panel, the Spring panel.
That's why we have a change in the room E, on stage E. We exchanged the second and the third talk, because the third talk will be now Spring QA panel with Josh Long, Evgeny Borisov, and so on.
Spasiba. Thank you so much for this. Thank you.